Assalamu alaikum. So we want to DC sweep. We want to sweep this value, this voltage value, and we want to see what happens. We will find the voltage across this transistor, current, and also the power dissipated in this IGBT. Well, so whatever, let's start. So first of all, we have to go to the graph mode, then click on the DC sweep and make a DC sweep window here, and then let's take a voltage probe and put it here, and let's make the name V. Then again take a current probe and place a current probe here, double click on the current probe and make it whatever you want. So I have choose V and I. Okay, so now right click here, drag object and place it here. Then again right click on the current probe and place it here. So you see, okay, let me do one thing. Right click on the DC sweep window, then maximize. Then you can see this window has been maximized, and you can see here I and V. Okay, now let's right click here, then edit graph, and we want to sweep the value from 0 to, let's say, 15. And another thing, we have to set a sweep variable here. So let's go to the schematics capture and let's write here we want to sweep this value. We don't want this fixed value, so click on 10, and instead of 10, let's say the value should be Vx or whatever you want. So remember this Vx because we have to put this Vx here, and we want to sweep from 0 to 15 volt, and number of steps will be 5. Let me take 500. The more you will take, the more the graph will be smooth. Okay, so press OK, and now press, you see the x-axis has been 0 to 15 volt, and now you have to press spacebar of your keyboard. So after pressing spacebar, you can see the green is voltage and the red is current. As the current is in milliampere range, so you can see the current properly. So what can you do? Right click on the current or double click on the current, right click on the current, double click on the current. Okay, why this not happening? Okay, I found it. Just right click on the current, then you can see that edit trace properties, and you can well, let me do another thing. Let's right click here and delete this trace. Okay, so now you have only voltage, and you don't want to plot voltage and current in the same axis. You see you have a axis at the right, and this is the voltage, and let's say you want to plot the current at the left axis. So right click here, add traces, then right here probe, then select I. So you see you have select I, and then right here current or whatever you want, but you have select this I probe. This I probe is actually the current, and then choose left axis. That means this axis will be plot here. Press OK. Now you see your current is now at the left. Now click the space bar, and you can see that now no problem occurs here, because at the left you have 0 to 200 milli, and at the right you have 0 to 20 volt. And now it's the time to plot the power. So what can we do? Again right click, add traces. Now click here, choose I, click here, choose B, choose here, choose V. Okay, And now we know that the power is actually the multiplication of current and voltage, so you have to multiply the P1 and P2, where P1 is I, P2 is V, and name it. It is actually power, and I want to plot this thing at the left axis. Okay, so you see the left axis, we have a left power at the left axis. And now if I press the space bar, you can see that the red is now power. And we can do another thing to see it more accurately. Right click on the power, edit properties, show data points, again spacebar, and you can see now we have dotted lines. And if you want a more smooth graph, you see the graph is not so smooth here. You want a smoother graph, then right click, edit graph, and increase the number. Instead of 500, let's say 1000. Then press spacebar, and you can see now the graph is smoother. If you want more smooth, then you can increase it more, let's say 2000. But maybe it will take a lot of time. Let's simulate it. Simulate graph. Now you see this graph is more smooth than the previous. Well, so this is the technique to plot the power, and you can see that between the switching period the power is high. You see at the beginning, actually what I am doing here, I am actually increasing the gate voltage, and increasing the gate voltage will make this voltage short. That means we are actually switching, right? If I increase this voltage from 0 to 15 volt, then gradually this voltage will be decreased and the current will increase. That means we actually kind of switching. So you can see that actually at the switching moment, you can see that from here to here you are actually switching, but at the time of switching moment, you can see that the power is too much here, maximum here, then again decreased.